Welcome back to AI.Code.Cast. Today, we're diving into a pretty common coding problem. Like imagine you've got this database, it's packed with product information, and your goal is to find specifically the products that are both low-fat and recyclable.
Oh yeah, filtering. Classic problem. Pops up everywhere. Data analysis, software development, you name it.
Exactly. So to make this a bit more concrete, let's say we've got a database table. We'll call it products. Simple enough. And each product has a producted filler. And then we'll just have, simple Y or N values for low fats and recyclable.
Straightforward structure, but, the code to actually find those healthy A&D eco-friendly options, that's where things can get, well, interesting.
Right. And before we jump into the really clever solutions, I think it's worth talking about that first thought, right? The one most programmers have, that brute force approach.
Oh, yeah. The check every single item method. Tried and true sometimes.
Yeah, precisely. It feels intuitive at first. You think, okay, is this product low fat? Yes.
Yeah.
Good. Is it also recyclable? If so, great, grab the ID. But as our database grows, this gets really slow.
The problem with brute force, it works, but the efficiency just tanks as the data grows. We're talking ON complexity here, meaning the time it takes is directly tied to the number of products. Not ideal for, well, huge data sets.
So brute force is out. What's the smarter way to go about this? What tools can we bring in to make this filtering process better?
Well, a couple of powerhouses come to mind. SQL, the language of databases, practically. And then there's Pandas, a Python library specifically designed for data manipulation.
Okay, so let's start with SQL. It's practically synonymous with databases, right? I remember from my early coding days, it felt like magic for searching through data.
Yeah, it is quite powerful. SQL, or structured query language, as it's formally known, gives us a very, very structured way to talk to databases. And the efficiency for filtering, major advantage.
So how would we actually write a SQL query to solve this whole low-fat recyclable product hunt? Like, how do we translate that into SQL?
Okay, imagine this. You walk into a grocery store, right? And you ask the staff, hey, can you point me to the aisle with stuff that's both low-fat and recyclable? That's basically what we're doing with SQL. We use a select statement to say what we want, in this case, just the producted of those special items. And then we say what table to look in with from products.
Got it. So we're telling the database what to grab and where to look.
Yeah.
But how do we add that filtering logic, that both criteria?
That's the where clause. It's like giving those grocery store workers that extra instruction, right? You're saying, okay, but only show me the stuff that meets these conditions. In this case, the condition is low fats Y equals Y and recyclable Y.
Ah, okay. So the and D is key here. It's like that really strict shopping list, no compromises. It must be both.
You got it. And SQL handles this, well, beautifully. It'll filter the rows based on that where clause first, gets rid of anything that doesn't meet both conditions, then it applies the select to what's left, and boom, we've got our producteds, just for those healthy A&D eco-friendly products.
SQL makes it sound almost too easy. And efficiency-wise, we talked about how brute force was ON. How does SQL compare performance-wise?
Well, it depends. SQL's efficiency can vary. The key factor is indexes. Think of them like the organized aisles in that grocery store we were talking about.
I see. So if our database has indexes set up on those specific columns, on low fats and recyclable, it's like the staff knows exactly where to go instantly.
Exactly. With the right indexes, the database can jump right to the relevant rows. No need to scan every single product. That means we could get a time complexity closer O-login way faster than O-on.
Got it. Indexes like turbocharging our searches. Makes sense. But SQL isn't the only option, is it? What about using Python and that Pandas library we mentioned for this same task?
Thinking like a true coder. Pandas IS powerful, especially if you're already working with data in a Python environment.
Yeah, I've heard a lot about Pandas being this data manipulation superstar. How would it tackle this problem? Like, would it be totally different from how SQL does it?
Let's change our analogy a bit. Instead of the grocery store staff, imagine you've got a giant spreadsheet. All the product info is laid out in front of you. Pandas lets you apply filters directly to the column ends of this spreadsheet. It uses something called Boolean indexing. Basically, it creates a set of true or false values for each product based on whether it meets your criteria.
So it's like labeling each product on the spreadsheet. Big, yes, this one works, or no, skip this one.
Exactly. And Pandas is efficient with this. It avoids those explicit loops, which can be slow. It applies filters to entire columns all at once, so it's very fast, especially for large data sets.
So SQL and Pandas, Both good for filtering, but different approaches. Sounds like SQL might be the more natural choice if you're like directly working with the database, while Pandas is great when the data is already in a Python environment.
You got it. The best choice often just depends on, the context, what your project is, what tools you're already using, that kind of thing.
This is great. We've got two distinct ways to find our low-fat, recyclable products, each with its own advantages. And there's so much more to explore.
Indeed. We're just getting started. Lots more to learn about these approaches, the nuances, when one might be a better fit than the other.
Stay tuned, everyone. We'll be back in just a bit to unpack even more about SQL and Pandas in part 2 of our deep dive.
Welcome back to AI.Code.Cast.
We're really digging into this whole idea of filtering, finding those perfect low-fat A&D recyclable products.
Yeah, before the break, we went from that brute force method all the way to the world of SQL and the flexibility of Pandas.
Right? We saw how SQL's like having this super organized database librarian. They can just instantly grab the products we need using the where clause and the power of that Andy operator.
And then with Pandas, it's like treating our data like a supercharged spreadsheet, just applying filters right to the columns with that Boolean indexing trick.
It's amazing how they both do the same thing, ultimately, but the logic behind them is so different.
Totally. And now that we've got kind of the basics down, I think it's time to get a bit deeper into the differences. SQL versus Pandas for this filtering task.
Yeah, let's do it. What kinds of things should we be thinking about when we're deciding which tool is right for a project?
One of the first things is, well, where's the data? Where does it actually live?
Right. Location, 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 as they say.
Exactly. If your product info is already in, say, a Pandas data frame right there in your Python code, well, Pandas is just often the easiest choice. You can apply those Boolean filters directly. No need to mess around with a separate database.
Yeah, it keeps things simple. But what if our data is sitting in a dedicated database?
Then SQL is your go-to. It was made for talking to databases. Its syntax, the way it's written, it's all optimized for querying, filtering, even on massive amounts of data.
Okay, so data location is a big one. What about the size of the data? Does that play a role in whether we pick SQL or Pandas?
It does. Both SQL and Pandas can handle, big data sets. But their efficiency, how well they perform, it can depend on how the data is structured and, crucially, on whether indexes are set up correctly.
Indexes, right? Those were like the organizational backbone of the database, allowing for those super fast searches.
You got it. In SQL, having good indexes can speed up queries by, a ton. It can get us closer to that O log n time complexity we like. And Pandas has its own indexing, too, which can really help performance.
So no matter what tool we're using, thinking about indexes is a good habit to get into.
Couldn't agree more. Now, what if our filtering needs get kind of tricky? Like, what if we want to combine multiple conditions, maybe using A and D or R, or even comparisons based on other columns?
Oh, that's a good point. Our low-fat recyclable thing, it's pretty basic. But in the real world, those requirements can get a lot more complex.
For sure. And this is where SQL really, really shines. It's got this expressive syntax that lets you build really precise queries, combining all sorts of conditions using logical operators, even incorporating subqueries to filter based on stuff from other tables.
Okay, so if we wanted, say, products that were low-fat or recyclable, or maybe filter by a certain price range or a product category, SQL can handle that.
Absolutely. You could just tweak that where clause, add in those extra conditions, use or operators, comparison operators like greater than or less than, and even those subqueries to pull in data from elsewhere.
SQL is pretty versatile then for handling all that. What about Pandas? Can it keep up with that level of complexity?
Oh, Pandas can get complex too. You can chain conditions together, use various comparison operators. You can even define your own functions to apply to the data.
So both tools are pretty capable when it comes to that kind of logic.
Hmm.
Are there any scenarios where one might be, I don't know, a bit better performance-wise or maybe easier to use?
Well, one thing Pandas is really great for is when you need to, do more than just filter, when you need to manipulate the data in more, I guess, advanced ways. It's got tons of functions for grouping data, doing calculations, transforming values, even making visualizations. And it's all, within that Python environment.
So if we wanted to, for example, find the average price of all our low-fat A&D recyclable products, or group them by category and make a chart, Pandas would be a good fit for that.
Exactly. Pandas is super popular with data scientists, analysts, anyone who's really digging into data and trying to understand it.
It's cool to see how both SQL and Pandas have their own strengths.
Yeah.
And I think I'm getting a better sense of when you choose one over the other.
That's the takeaway here. There's no, one perfect solution. The best tool, it just depends. What's the project? What kind of data do you have? What are you trying to do with it?
Right. The right tool for the job. But before we move on, are there any common mistakes, gotchas, things people should watch out for when they're filtering data, no matter what tool they're using?
Oh, that's a great question. One thing that trips people up, both beginners and experienced folks, is data types. Not paying close enough attention to them and how they affect comparisons.
Oh yeah, I've definitely fallen into that trap, like
Oh.
accidentally trying to compare a number to some text or mixing up uppercase, lowercase letters when filtering.
Exactly. Those little mismatches can lead to weird results or even errors.
Yeah.
Always double check those data types. And make sure you're using the right operators for the comparison you're doing.
Good reminder. Any other words of wisdom for people who want to become like data filtering masters?
Another one is NUL values. Those empty cells in your data, they can behave differently in comparisons depending on the database or the library you're using.
Right. NULs can be tricky. What should we keep in mind about them?
Just understand how your tool handles them. Make sure you're using the right operators to deal with their presence. Otherwise, you might get incomplete results or just wrong results.
So be mindful of those NLLs and how they might mess things up. Anything else before we wrap up this part?
One last tip, testing. Always test your queries, test your filters. Start with small data sets just to make sure you're getting what you expect before you go and apply it to, huge amounts of data.
Good point. Testing is crucial for any coding, and data filtering is no exception. We want to be sure we're getting those right products, whether we're using SQL, Pandas, or anything else.
We've covered a lot in this part, compared SQL and Pandas, talked about their strengths and weaknesses, and even, pointed out some things to watch out for.
In the final part, we're gonna shift gears a bit. We'll look at how all these concepts translate into actual code. We'll sketch out the logic using pseudocode.
Stay tuned for the grand finale of our data filtering adventure.
Welcome back to AI.Code.Cast for the final part of our deep dive. We've been looking at how to filter for those low-fat A&D recyclable products.
Lots of ground covered, right? Explored the problem itself, compared SQL and Pandas, those powerful tools, even talked about some common mistakes.
Yeah, it's been quite a journey from brute force methods all the way to the elegance of these specialized tools.
And now it's time to connect those high-level ideas to the actual code we'd write.
Exactly. We've talked about the logic, the concepts,
Yeah.
but I think it would help to see it like a bit more concretely. What if we sketched out the steps using pseudocode, something that captures the essence of the code without getting too bogged down in the specific syntax?
Pseudocode, yeah, that's a great idea. Really effective way to communicate how a program flows without those little details getting in the way.
Okay, so let's start with the SQL approach.
Okay.
Imagine we're writing pseudocode for a function. We'll call it, how about get low-fat recyclable product Scorolo?
Nice, descriptive name. All right, so inside this function, the very first step would be to establish a connection to our database.
Right, like opening up a communication channel to that storehouse of product information.
Exactly. Once we've got that connection, we build our SQL query as a string.
And that query would have, all that logic we've been talking about, selecting the producted, telling it what table to look in, and then, of course, that all-important where clause with our end condition.
I got it. It'll look something like this in the string. Select producted from products where low fats equals Y and recyclable Y. That's what we send to the database.
Okay, so we've built our query. What's next in the pseudocode?
Well, next, we'd use that database connection to execute the query. It's like sending our request, carefully written out to the database server.
And the database would process it and send back the results, a list of those producteds that match what we're looking for.
Precisely. At that point, our pseudocode could have steps for what to do with those results. Maybe store them in a variable, display them to the user, or use them as input for some other part of the program.
Like a recipe almost,
Yeah.
step by step for how to talk to the database and get that information we need. Pseudocode makes it really clear.
Now, how about we sketch out some pseudocode for the pandas way? We could call this one "Get Low-Fat Recyclable Products Pandas," maybe.
Okay. And here we're assuming we already have our product data loaded up
Yeah.
into a Pandas data frame in our Python environment, right?
Right, exactly. So first step here would be to apply those Boolean filters directly to the DataFrames columns.
That labeling technique we were talking about, right? Marking each product as either a match or not a match.
Yeah. In pseudocode, it might look like this. We create a new variable, let's call it filtered products, and we set it equal to a subset of our original data frame, the subset that meets those conditions, checking if low fats is Y, A&D recyclable is also Y.
So we're basically creating a new data frame that only has those rows where both conditions are true.
Yeah, exactly. And then our pseudocode could have steps to grab the producted column from that filtered data frame, just like we did with the SQL results.
This is great. We've gone from like this conceptual understanding of SQL and Pandas to actually visualizing the code, the steps involved. Pseudocode is really helpful for that.
And remember, this is simplified. The real code might have, error handling or data type conversions or other stuff. It all depends on the specific situation.
This whole deep dive has been so insightful. We've looked at this problem from all these different angles, compared solutions, walked through the logic. It's been amazing.
It's all about giving you, our listeners, the knowledge and the tools so you can confidently tackle these data filtering challenges in your own coding.
And whether you go with SQL or Pandas or some other method, the important thing is to understand those core concepts, pick the right tool, and of course, always test your code.
We've given you a good foundation here, but there's always more to learn. One last thing to think about. How would our SQL and Pandas approaches change if we had like really complex filtering with lots of A&Ds and ORs or maybe even calculations based on other columns? That's something you can explore on your own.
Great challenge to leave our listeners with. Keep experimenting, keep learning, and keep pushing the boundaries of what you can do with code.
Thanks for joining us on this deep dive into data filtering. Until next time, happy coding.
Happy coding, everyone.